Okay. Find the exact value of each expression. This is an important question. Question like that or similar. They got it before in college. I've seen it on different tests. And cosine of cosine inverse plus sine inverse. Actually, don't confuse because this is technically it's an angle. It's an angle. That means what is the angle that its cosine is the square root of 2 over 2? We assume that this is x, alpha, a, whatever. And this is also an angle. The inverse of sine is the square root of 3 over 2 means what is the angle that its sine is square root of 3 over 2? We assume that this is y. So we're going to express it as cosine of x plus y. When you expand it, it will be cosine minus, I'm going to switch positive to be negative, sine cosine of x cosine of y minus sine of x sine of y. So let's work on that here. If you're getting this question, so you're gonna say, oh, okay, assume that x equals inverse of cosine of square root of 2 over 2. You could express it as 1 over square root of 2 over 1. Express it as 1 over square root of 2 if you want to do that. And you could find that if you take cosine of both sides, left side and right side, if you take cosine in here, so it will be cosine of x. And if you take cosine here, cosine inverse cancel out, just 1 over square root of 2 left. So we'll do it as cosine x equals cancel out and then 1 over square root of 2. To find the missing ratio sine, because as we got cosine, we need sine. You could apply Pythagorean theorem, different methods, you could apply identities, sine squared plus cosine squared equals 1. You plug it in and to find sine. Or you could do Pythagorean theorem, super easy for you. So cosine of this angle is adjacent, which is 1, over hypotenuse. So it's adjacent over hypotenuse, square root of 2. And this must be u square root of 2, which is 2. U square 1 is 1. 2 minus 1 is 1. Square root of 1 is 1. Then you could find sine, and it's the same. Sine of x equals opposite over adjacent, which is 1 over square root of 2. So you got this and you got this. And we need to work on y too. Here, y. So if you got this, y equals inverse of sine of square root of 3 over 2. And you want to take the opposite of the inverse sine, which is sine. It takes sine of both sides. So it takes sine of this, and it takes sine of this. Sine of left equals sine of right. If you do that, then sine of y, you replace it as sine of y equals, and here is sine and the inverse of sine cancel each other, and just the square root of 3 over 2 left. So you got already sine. And if you want to find cosine, you could apply Pythagorean theorem. Here, if this is right triangle and this is our angle, sine, that means the opposite is the square root of 3 and the hypotenuse is 2. Opposite over hypotenuse. To find the missing side, just square, subtract. Square 2 is 4. Square radical 3 is 3. 4 minus 3 is 1. Then radical it's 1. So you could find cosine of y equals adjacent over hypotenuse, which is a half. Now you're going to plug in all of these ratios. So Cosine of x is 1 over square root of 2. Cosine of y is a half minus sine of x is 1 over square root of 2, and sine of y is square root of 3 over 2. I don't mind if you multiply it like that, I give right to all students who just multiply and then simplify. But you could convert 1 over square root of 2 to be square root of 2 times a half, and you combine it together. Make it nice. No radical in the bottom. So 1 times square root of 2 is square root of 2. Divide by 2 times 2 is 4. And here is square root of 3, and you could convert this to be square root of 2 over 2. Square root of 3 times square root of 2 is square root of 6. Divided by 2 times 2 is 4. So all you have to do, make it square root of 2 minus the square root of 6 divided by the common denominator 4. And please, please, please do not subtract square root of 2 minus square root of 6 to make it square root of 4. That's wrong. Just this is the answer. Keep it like that. Square root of 2 minus the square root of 6 divided by 4.